Hello all, welcome back to our channel. Today we are going to discuss about our second exercise. So the second exercise is about transpose of a matrix, symmetric of a matrix, skew symmetric matrix, and so on. So our first topic is transpose of a matrix. So the definition of transpose of a matrix is the matrix obtained from the given matrix A by interchanging its rows and columns is called transpose of matrix A, and it is denoted by A transpose. So interchange just rows and columns. So the transpose of a matrix is denoted by A transpose. So simply the transpose of a matrix is interchanging of rows and columns, and it is denoted by A transpose. For example, if A is equal to 1, -1, 0, 3, 5, 2, 5, 4, 2, 1. So this is the matrix A. Here we have to do the transpose for this given matrix. Therefore, A transpose is equal to. So here the order of the given matrix is row 1, row 2, column 1, column 2, column 3, column 4, column 5. So 2 rows of 5 columns. So it is 2 by 5 matrix. Now the obtained matrix, that is transpose of a matrix, is of order 5 cross 2. That is, you will get 5 rows and 2 columns. So here we have to write 1, 2, -1, 5, 0, 4, 3, 2, 5, 1. So this is the obtained transpose of a matrix, and the order of this matrix is 5 cross 2. So here we are having 5 rows and 2 columns. So order of the matrix changes as 2 cross 5 to 5 cross 2. Now let us see what are the properties of transposes. So here we are having total 5 properties. First one is, this is important property, A transpose whole transpose is equal to A. So if you do transpose twice to the given matrix, then you will be getting the matrix itself. Then next, second one is A plus B whole transpose is equal to A transpose plus B transpose. Similarly, A minus B whole transpose is equal to A transpose minus B transpose. So this is addition, subtraction. Now multiplication is A into B whole transpose is equal to B transpose into A transpose. And our last one is K is constant. K into A whole transpose equal to K into A transpose. So these are the 5 properties of transpose. So here in multiplication we have taken only 2. Suppose if we consider A into B into C into D into E into so on up to Z transpose, then you will be getting Z transpose, Y transpose, X transpose, W transpose, so on up to A transpose. This is the generalization of fourth property. So in general, we will be getting only 2 matrices, A into B whole transpose equal to B transpose into A transpose. Now let us see some definitions. Symmetric and skew symmetric matrices. Symmetric matrix. A matrix A is said to be symmetric matrix. It satisfies one condition. If A transpose is equal to A, then we should call that matrix as symmetric matrix. So every symmetric matrix is of the form, that is standard form. Standard form of symmetric matrix is AHG, HBF, GFC. So this is the standard form of a symmetric matrix. For example, if you consider a matrix A is equal to, then we can create any number of matrices from this standard form. So here in place of ABC I am taking 4, 5, 6, and HH, in place of H I am taking 1, 1. In place of G I am taking GG, 2, 2. In place of F I am taking 3, 3. So this is a symmetric matrix. If you do transpose for this matrix also, you will be getting the same answer. So 4, 1, 2 is in row wise. If you write in column wise, you will get getting 4, 1, 2, 1, 5, 3, 1, 5, 3, 2, 3, 6, 2, 3, 6. Same matrix. Therefore, A transpose is equal to A. So any matrix which satisfies the condition A transpose is equal to A, then we should call that matrix as symmetric matrix. And any symmetric matrix is of the form AHG, HBF, GFC, which is the standard form for a symmetric matrix. If you remember the standard form, then we can create any number of symmetric matrices from this standard form. So simply you can remember like this: a handsome girl having a boyfriend go for a cinema. So like this also you can remember. Now let us see what is skew symmetric matrix. So here our next definition is skew symmetric matrix. So any matrix is said to be a skew symmetric matrix if it satisfies one condition, that is A transpose equal to minus A. So if A transpose equal to plus A, then we should call that matrix as symmetric matrix. If A transpose equal to minus A, then we should call that matrix as skew symmetric matrix. So here the standard form is if we remember one standard form, then we can create any number of skew symmetric matrices. So here 0, 0, 0. So in a skew symmetric matrix, all the diagonal elements must be equal to 0 only. So here H minus H, G minus G, F minus F. Simply we can remember positive, negative, positive, negative, positive, negative. So this is the standard form for skew symmetric matrix. For example, let us create one example. A is equal to 0, 0, 0, 1 minus 1, 2 minus 2, 3 minus 3. Like this we can create any number of skew symmetric matrices. Here we have one important note. So that is note: every square matrix can be expressed as, this is important note, every square matrix can be expressed as the sum of symmetric and skew symmetric matrices. So this is the important note now. So that is A is equal to A plus A transpose by 2 plus A minus A transpose by 2. So this is one of the important note here. Here the first one is symmetric and the second one is skew symmetric. So here any square matrix A can be converted to a symmetric matrix if it is not in the form of symmetric matrix by using the simple procedure A plus A transpose by 2. And similarly, every square matrix which is not in the form of skew symmetric matrix can be converted to skew symmetric by using the simple procedure A minus A transpose by 2. This is one of the important note. You will be getting one question from this topic. So here in your exercise you can see now these are the review questions. So here the first question is define transpose of a matrix. So in the very beginning of the class I have explained about transpose of a matrix definition. So every square matrix is said to be transpose of a matrix, and the transpose of a matrix can be obtained by interchanging the rows and columns. So our second question is define symmetric matrix. So any square matrix A is said to be symmetric if it satisfies one condition, that is A transpose equal to A. So define symmetric matrix and give one example. These two questions are same. So here you can write one standard form to the symmetric matrix. Next question is define skew symmetric matrix. So this is also I explained now. Give one example. Here I have explained one standard form for every symmetric and skew symmetric matrices. So here the question is also same. Define symmetric and skew symmetric matrices with examples. So these questions you can be answered very easily. Now let us go for our exercise. So here you can see the exercise 3.2. So in this exercise you will be having A plus A transpose, mean A into A transpose means addition and multiplication. Here proofs or verifications of properties of transposes. So these are all the proofs related to properties of transposes, and in the next page you will be having find the value of x and express the given matrix into sum of symmetric and skew symmetric matrices. So let us discuss all these questions now. So our first question is addition. So here our first question is, if A is equal to 2 minus 4 minus 5 3, then find A plus A transpose and A into A transpose. So first of all let us find A transpose or transpose of matrix A. So A transpose is equal to, so simply the transpose of a matrix will be getting by interchanging rows and columns. So 2 and minus 4 is in the row, so simply we should write in column. Minus 5 3 is in row, then we should write in column. So this is the transpose of matrix A. Then we have to find A plus A transpose, which is equal to A plus A transpose. So here copy paste A matrix 2 minus 4 minus 5 3. Then here we have to copy paste A transpose 2 minus 5 minus 4 3. So then we have to do addition, which is equal to 2 plus 2. Simple addition. add first element with first element, second element with second element, third element with third element, fourth element with fourth element. So minus 4 minus 5 minus 5 minus 4, 3 plus 3. Therefore A plus A transpose is 2 plus 2 4, minus 4 minus 5 is minus 9, minus 5 minus 4 is again minus 9, 3 plus 3 is 6. So this is the solution for A plus A transpose. Now we are doing A into A transpose. So multiplication of A into A transpose. So first of all we have to write A and A transpose matrices. So here this is into. So 2 minus 4 minus 5 3, 2 minus 5 minus 4 3. So here first row is multiplied with first column. So 2 into 2 is 4, minus 4 into minus 4 is 16. Similarly first row is again multiplied with the second column. So you will be getting 2 into minus 5 is minus 10, minus 4 into 3 is minus 12. And now we have to multiply second row with first column. So minus 5 into 2 is minus 10, 3 into minus 4 is minus 12. And similarly we have to multiply second row with second column. Minus 5 into minus 5 is 25, 3 into 3 is 9. So like this you have to do. So our answer is 16 plus 4 20, minus 10 minus 12 is minus 22, minus 10 minus 12 is again minus 22, 25 plus 9 is 34. So this is A into A transpose. Like this you have to do all the problems in your exercise. Here comes under second question. So it is, express the given matrix A in the form of sum of symmetric and skew symmetric matrices. This is one of the important question and it will come for 3 marks answer. So here they have given the question A equal to 213 114 minus 162. Here this matrix is not a symmetric matrix and this matrix is also not a skew symmetric matrix. Now we are going to convert this matrix into symmetric and skew symmetric matrix. So here I have explained about the conversion of symmetric matrix. So that is A plus A transpose by 2 is symmetric matrix. So here first of all we have to find A transpose for the given question. So how we can find A transpose? By interchanging rows and columns we can write. So 2 1 3 is in row form. Directly you have to write in column. 1 1 4 in row. 1 1 4 in column. Minus 1 6 2 is in row. So minus 1 6 2 we should write in column. So this is known as transpose of a matrix. Now we have to add these two matrices in order to get symmetric matrix. So here A plus A transpose is equal to 2 1 3 1 1 4 minus 1 6 2 plus 2 1 minus 1 1 1 6 3 4 2. So here the addition is simple. In the previous class I have explained about how to do addition of matrices. So add first element to first element. So 2 plus 2. Second element to second element. 1 plus 1. Third element to third element. 3 minus 1. Fourth element to fourth element. 1 plus 1. Fifth element to fifth element. Again 1 plus 1. Sixth element to sixth element. 4 plus 6. Seventh element to seventh element. Minus 1 plus 3. Eighth element to eighth element. 6 plus 4. Ninth element to ninth element, that is 2 plus 2. So like this you have to do the addition. Then you can simplify now. So 2 plus 2 is 4. Next 1 plus 1 is 2, 3 minus 1 is 2, 1 plus 1 is 2, 1 plus 1 is 2, 6 plus 4 is 10, 3 minus 1 is 2, 4 plus 6 is again 10, 2 plus 2 is 2. So this is A plus A transpose. After getting A plus A transpose, then we have to do by 2. Therefore, A plus A transpose by 2 is equal to 4 by 2, 2 by 2, 2 by 2, 2 by 2, 2 by 2, 10 by 2, 2 by 2, 10 by 2, 2 by 2. Therefore, symmetric matrix is equal to, so 2 ones are 2 twos are, so 2 ones are 2 ones are will get cancelled, 2 will get cancelled, 2 will get cancelled, 2 will get cancelled, 2 ones are 2 fives are, 2 will get cancelled, 2 ones are 2 fives are, so 2 will get cancelled. Now the given question is in the form of symmetric matrix. So here you can check once whether it is in symmetric or not. So every symmetric matrix is of the standard form AHG, HBF, GFC. సో ఈ స్టాండర్డ్ ఫామ్తో కంపేర్ చేసి చూడండి. ఏ ప్లేస్లో 2 ఉంది, బి ప్లేస్లో 1 ఉంది, సి ప్లేస్లో 1 ఉంది, అండ్ రిమైనింగ్ 2 హెచ్ఎస్ ఆర్ 1 1, అండ్ రిమైనింగ్ 2 జీస్ ఆర్ 1 1, and remaining 2 f's also 5 5. So hence the given question is converted to symmetric matrix successfully. Now we should convert the given matrix to skew symmetric matrix. Now we have to convert the given question to skew symmetric matrix, that is A minus A transpose by 2 is equal to skew symmetric matrix. So here already we are having A and A transpose. Simply we should write these two matrices, and in between them we have to put minus symbol. Therefore A minus A transpose is equal to 2 1 3 1 1 4 minus 1 6 2 minus 2 1 minus 1 1 1 6 3 4 2. Now we have to do subtraction. Simple process. Already I have explained how to do subtraction. Subtract first element from first element, that is 2 minus 2. Next 1 minus 1. Next 3 minus of minus is plus 1. 1 minus 1. 1 minus 1. Again 4 minus 6. Minus 1 minus 3, minus 1 minus 3, 6 minus 4, 6 minus 4, 2 minus 2, 2 minus 2. So like this you have to do subtraction. Then after you will be getting the answer as 2 minus 2 is 0, 1 minus 1 is 0, 3 plus 1 is 4, so 0 0 4. Next 1 minus 1 is 0, 1 minus 1 is again 0, 4 minus 6 is minus 2, 1 minus 1 minus 3 is minus 4, 6 minus 4 is 2, 2 minus 2 is again 0. So this is A minus A transpose. So after getting A minus A transpose, then we have to do multiply, divide with 2. So here after getting A minus A transpose we are doing by 2. So 0 by 2, 0 by 2, 4 by 2. You will be getting the answer as 0 0, 2 ones are 2 twos are, 0 0 minus 1, so 2 ones are 2 twos are, minus 2 1, 2 will get cancelled, 0 by 2 is 0. So you can check here whether the given answer is in the standard form of skew symmetric matrix or not. So let us check. 0, 0, 2, 0, 0, minus 1, minus 2, 1, 0, which is equal to A, H, minus H, G, minus G, B, C, F, minus F. చెక్ చేయండి. ఏబిసి మస్ట్ బి ఈక్వల్ టు 0 ఉండాలి. సో 0, 0, 0. సో హియర్ 0, 0, 0 కంపల్సరీ ఏబిసిలు మొత్తం 0 ఉండాలి. దిస్ ఈజ్ వన్ ఆఫ్ ద ఇంపార్టెంట్ కండిషన్ విచ్ హ్యాస్ టు సాటిస్ఫై ఫర్ ఎవ్రీ స్క్యూ సిమెట్రిక్ మ్యాట్రిక్స్. అండ్ ద రిమైనింగ్ ఎలిమెంట్స్ హెచ్ మైనస్ హెచ్ రెండు సేమ్ ఉండాలి కానీ బట్ ఒకటి పాజిటివ్ ఒకటి నెగిటివ్ రావాలి. సో ఇక్కడ చూడండి, రెండు జీరోసే కాబట్టి అది పాజిటివ్ అయితేంది, నెగిటివ్ అయితేంది. నెక్స్ట్ జీలు రెండు సేమ్ ఉండాలి బట్ ఒకటి పాజిటివ్ ఒకటి నెగిటివ్. సో 2 మైనస్ 2. నెక్స్ట్ ఎఫ్లు రెండు సేమ్ ఉండాలి, ఒకటి పాజిటివ్ ఒకటి నెగిటివ్ రావాలి. సో హియర్ ఆల్సో ఒకటి పాజిటివ్ ఒకటి నెగిటివ్ వచ్చింది. నెగిటివ్ అనేది కిందనే రావాల్సిన అవసరం లేదు, కండిషన్ ఒకటి పాజిటివ్ ఒకటి నెగిటివ్ ఉండాలి అంతే. సో ఇక్కడ 1 పాజిటివ్ ఉంటే ఇక్కడ -1 నెగిటివ్ ఉంది. సో ఇట్ ఈస్ స్క్యూ సిమెట్రిక్ మ్యాట్రిక్స్. దేర్ఫోర్ our given question is 2, 1, 3, 1, 1, 4, minus 1, 6, 2 can be written as sum of symmetric and skew symmetric matrices. So symmetric answer is 2, 1, 1, 1, 1, 5, 1, 5, 1. And our skew symmetric answer is 0, 0, 2, 0, 0, minus 1, minus 2, 1, 0. Here you can check whether our answer is right or wrong. So here 2 plus 0 is 2, 1 plus 0 is 1, 1 plus 2 is 3, 1 plus 0 is 1, 1 plus 0 is again 1, 5 plus into minus minus 1, 5 minus 1 is 4, 1 plus into minus is minus, 1 minus 2 is minus 1, 5 plus 1 is 6, 1 plus 0 is again 1. So here 2 plus 0 is 2. So like this you can solve the questions given in your second exercise. Now let us prove the properties of transposes. So here we have proved that AB whole transpose equal to B transpose into A transpose. Now we are proving the properties of transposes. So in this we are having A matrix and B matrix. First of all we have to do LHS, then after we have to do RHS, then we have to verify whether LHS is equal to RHS or not. So in order to LHS, then we have to do A into B matrix multiplication. So first A into B, write A and B matrices and put one dot between these two matrices. So 1 minus 1 0, 2 1 3, 4 1 8. Similarly B matrix 4 1 0, 2 minus 3 1, 1 1 minus 1. Then we have to multiply first row with first column to get A into B. So here multiply first row with first column. 1 into 4 is 4, minus 1 into 2 is minus 2, 0 into 1 is 0. So next multiply again first row with second column. 1 into 1 is 1, minus 1 into minus 3 is plus 3, 0 into 1 is 0. Then you have to multiply this first row with third column. 1 into 0 is 0, minus 1 into 1 is minus 1, 0 into minus 1 is 0. So like this you have to do for remaining two rows. So multiply second row with first column. So 2 into 4 is 8, 1 into 2 is 2, 3 into 1 is 3. Similarly, I have to multiply second row with second column. 2 ones are 2, 1 into minus 3 is minus 3, 3 into 1 is 3. And we have to multiply second row with third column. 2 into 0 is 0, 1 into 1 is 1, 3 into minus 1 is minus 3. Now we have to multiply third row with first column. 4 into 4 is 16, 1 into 2 is 2, 8 into 1 is 8, 4 into 1 is 4, 1 into minus 3 is minus 3, 8 into 1 is 8. Now in the last we have to multiply third row with third column. 4 into 0 is 0, 1 into 1 is 1, 8 into minus 1 is minus 8. Like this you have to multiply two matrices. So then after we have to simplify. A into B equal to 4 minus 2 is 2, 1 plus 3 is 4, minus 0 minus 1 is minus 1, 8 plus 2 is 10, 10 plus 3 is 13, plus 3 minus 3 will get cancelled, so remaining 2, 1 minus 3 is minus 2, 16 plus 2 is 18, 18 plus 8 is 26. Next 8 plus 4 is 12, 12 minus 3 is 9, 1 minus 8 is minus 7. Therefore after getting A and B we have to do AB whole transpose, which is equal to transpose of any matrix can be obtained by interchanging rows and columns. So 2, 4, minus 1 is in the form of a row. Now we should write it is in the form of a column. 13, 2 minus 2 is in row form. We should write in column form. And similarly 26, 9 minus 7 is in row form. We should write in column form. So like this you have to solve LHS. So this is all about LHS. Now we have to do RHS. RHS is B transpose into A transpose. So B transpose is equal to, so here we are doing B transpose. Just interchange rows and columns in matrix B. That is 4, 1, 0 is in row form. We have to write in column form. 2 minus 3, 1 is in row form. We have to write in column form. 1, 1 minus 1 is in row form. We have to write in column form. Similarly A transpose. 1 minus 1, 0 in row form. We have to write in column form. 2, 1, 3 is in row form. We have to write in column form. 4, 1, 8 is in row form. We have to write in column form. So after getting B transpose matrix and A transpose matrix, then we have to multiply these two matrices now. So in order to multiply B transpose into A transpose, first of all we have to write those matrices now, and in between them we have to put one dot. So here similar process we have done earlier. Multiply first row with first column. So 4 into 1 is 4, 2 into minus 1 is minus 2, 1 into 0 is 0. Similarly multiply first row with second column. So 4 into 2 is 8, 2 into 1 is 2, 1 into 3 is 3. Now multiply first row with third column. 4 4s are 16, 2 1s are 2, 1 8s are 8. Now repeat the same process with second row. So second row is multiplied with first column again. 1 into 1 is 1, minus 3 into minus 1 is plus 3, 1 into 0 is 0. Now multiply second row with second column. 1 into 2 is 2, minus 3 into 1 is minus 3, 1 into 3 is 3. Now multiply again second row with third column. 1 into 4 is 4, minus 3 into 1 is minus 3, 1 into 8 is 8. Now repeat the same process with the third row. So 0, 1 minus 1 is multiplied with 1 minus 1, 0. So 0 ones are 0. 1 into minus 1 is minus 1. Minus 1 into 0 is 0. Next, multiply third row with second column. 0 into 2 is 0. 1 into 1 is 1. Minus 1 into 3 is minus 3. Similarly, multiply third row with third column. 0 into 4 is 0. 1 into 1 is 1. Minus 1 into 8 is minus 8. So like this you have to multiply. After multiplication we have to simplify. 4 minus 2 is 2. 8 plus 2 is 10. 10 plus 3 is 13. 16 plus 2 is 18. 18 plus 8 is 26. 1 plus 3 is 4. Plus 3 minus 3 will get cancelled. 4 minus 3 is 1. 1 plus 8 is 9. 0 minus 1 is minus 1. 1 minus 3 is minus 2. 1 minus 8 is minus 7. So here LHS answer is 2, 13, 26, 4, 2, 9, minus 1, minus 2, minus 7. So here our RHS answer is similar to LHS 2, 13, 26, 4, 2, 9, minus 1, minus 2, minus 7. Therefore LHS is equal to RHS. Hence proved. Like this you have to prove all the proofs related to properties of transposes. Here our next proof is show that A plus B whole transpose equal to A transpose plus B transpose. So this is the second property in our properties of transposes. In previous question we have discussed about fourth property. So here first of all we have to do LHS, then after we have to do RHS and check whether LHS is equal to RHS. So here LHS is A plus B whole transpose. First of all we have to add A and B, then after we have to do transpose for the obtained answer. So here A plus B is equal to, simply copy paste A and B matrices from the question. 1, 4, 7, 2, 5, 8, 3, 6, 9, 1, 2, 3, 4, 5, 6, 7, 8, 0. So after copying from the question, then we have to do addition. Already I have told about addition of two matrices. So here 1 is added to 1. So 1 plus 1. 4 is added to 2. 4 plus 2. 7 is added to 3. 7 plus 3. Similar manner 2 is added to 4. So 2 plus 4. 5 is added to 5. 5 plus 5. 8 is added to 6. 8 plus 6. 3 is added to 7. 3 plus 7. 6 is added to 8. 6 plus 8. 9 is added to 0. 9 plus 0. So like this you have to do addition of two matrices A and B. Therefore you will be getting the answer as 1 plus 1 is 2. 4 plus 2 is 6. 7 plus 3 is 10. 2 plus 4 is 6. 5 plus 5 is 10. 8 plus 6 is 14. 3 plus 7 is 10. 6 plus 8 is 14. 9 plus 0 is 9. So after getting A plus B, then we have to do transpose for the obtained answer. Therefore A plus B whole transpose is equal to, simply interchange the rows into columns, you will be getting the answer for A plus B whole transpose. So 2, 6, 10 is in the form of row. Now we have to write in the form of column. 2, 6, 10. Next 6, 10, 14 is in row form. We should write in column form. Next 10, 14, 9 is in row form. We should write in column form. So this is the answer for A plus B whole transpose. Now we have to do RHS. RHS, that is A transpose plus B transpose. So in order to A transpose plus B transpose, first of all we have to find what is A transpose and what is B transpose. So here A transpose is equal to, in the similar manner we have to interchange rows into columns for matrix A to get A transpose. So here 1, 4, 7 is in row form. We should write in column form. 2, 5, 8 is in row form. We should write in column form. 3, 6, 9 in row form. We should write in column form. Similarly, B transpose is equal to 1, 2, 3 is in row form. We should write in column form. 4, 5, 6 is in row form. We should write in column form. 7, 8, 0 in row form. We should write in column form. So like this you have to find A transpose and B transpose. After getting A transpose and B transpose, then we have to add these two matrices. That is A transpose plus B transpose is equal to. Here you have to simply copy paste those two matrices which we have obtained in the previous page. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 1, 4, 7, 2, 5, 8, 3, 6, 0. So here I have copied A transpose and B transpose matrices which we have obtained in previous page. Now we have to do addition. So here first element is added to first element, that is 1 plus 1. Second element is added to second element, 2 plus 4. Third element added to third element, 3 plus 7. Fourth element added to fourth element, 4 plus 2. Fifth element added to fifth element, 5 plus 5. Sixth element added to sixth element, 6 plus 8. Seventh element added to seventh element, that is 7 plus 3. Eighth element added to eighth element, that is 8 plus 6. Ninth element is added to ninth element, 9 plus 0. So after writing like this, you have to simplify. 1 plus 1 is 2, 2 plus 4 is 6, 3 plus 7 is 10, 4 plus 2 is 6 again, 5 plus 5 is 10, 6 plus 8 is 14, 7 plus 3 is 10, 8 plus 6 is 14, 9 plus 0 is 9. So this is RHS. Now we have to compare whether LHS is equal to RHS or not. So here 2, 6, 10, 6, 10, 14, 10, 14, 9 is our RHS answer. Now you can check here our LHS answer. 2, 6, 10, 6, 10, 14, 10, 14, 9. So here both are same. Therefore you have to write LHS is equal to RHS. Hence verified or hence proved. Like this you have to do all the proofs related to properties of transposes. So here we have covered all the second exercise problems in this class. So here we have discussed about what are the definitions of transpose of a matrix and what are the properties of transposes, and then we have discussed about symmetric matrix and then skew symmetric matrix, and here we have discussed about the procedure to convert a square matrix to symmetric and skew symmetric matrices. Then after we have discussed about addition and subtraction and multiplication of two matrices related to transposes, and then we have discussed about how to convert a given matrix to symmetric and skew symmetric matrices, and then after we have proved properties of transposes. So here in this exercise, so this is your exercise 3.2. So here we have discussed all the models related to your exercise. Only three models we are having. First one is addition and multiplication. Second one is properties of transposes. Third one is convert the given matrix to symmetric and skew symmetric matrices. So this is about second exercise. So our entire second exercise is covered. Now you have to do all the problems related to your second exercise as your homework. So by this we can end up our class. Thank you all.